Hey kiddos, today we are starting Unit 5 with Lesson 1, which should be a review from Math 1. Alright, so let's jump right in and talk about some polynomials. A polynomial is a combination of products of variables and constants, separated by addition and subtraction. Okay? And then right underneath that, I reminded us of our exponent rules. As we work with multiplying polynomials, we will definitely need to be utilizing the product rule. We will also use the power rule on occasion and the quotient rule as well. So I just wanted to put those back here so that you did not have to go back in your notes to refer to them. All right, let's talk about how we classify polynomials. So this was supposed to print out in yellow for me, but that's all right. We classify polynomials by the value of their highest exponent. And then we call this exponent the degree. So I want you to think about when we discuss degrees. So here's an example, 27 degrees. The degree symbol is in the same place that an exponent would be. Okay, so we refer to that as the degree of the polynomial. Okay, so the leading term is going to be our degree. So let me zoom in on these. And I went ahead and I gave you an example of the highest degree in each polynomial, what it would look like visually if we were to graph it, and then the name of that based on the degree. Okay, so if the highest degree is 1, you can see y equals x plus 1. The exponent here is a 1, so this is a linear polynomial or a linear equation. What if the highest degree is 2? So the highest degree in this case is a 2. So we will have a single curve, okay? Goes up and then it changes direction and it comes back down. So it changes direction one time, okay? And that is referred to as a quadratic. If the highest degree is 3, I have a cubic, which looks like this. My highest degree is 4. I have a quartic, which looks like this, okay? It changes direction 3 times. And so it has 1, 2, 3, 4 different directions that it's going. Let's look at if our highest degree is 5, we call this quintic, okay? And again, it changes direction 4 times, and so it goes in 5 different unique directions based on what part of the graph you're looking at. Anything that is 6th degree or higher, we don't have a name for that. We just call it 6th degree or 7th degree polynomial, okay? So anything up to the nth degree. Alrighty. Let's take a look at our standard form of a polynomial. So in order to be in standard form, there it is, exponents must be in order from large to small. I should zoom out a little. Okay, our exponents need to be in order from large to small. And so we are going to look today at examples of polynomial operations that deal with both addition and subtraction, as well as multiplication. So when we're doing addition and subtraction, I want you to keep these notes in mind. We are combining like terms, so whether that's addition or subtraction is irrelevant. We're combining like terms with whatever signs they have between them. And then we need to keep in mind that the values of the exponents will not change at all. So let's go look at some examples of adding and subtracting. Alrighty, so here we go. So we have addition, okay? This is a 1 in front. So whenever you have something in front of a parenthesis, you do need to distribute that, okay? So positive 1 times 2x squared will not change the value of it. Positive 1 times negative 23 will also not change the value. And positive 1 times negative 5x. So when I distribute the positive 1, it does not change the value of anything. Let's bring down this first polynomial that I had. And now I'm ready to start combining my like terms. So let's look for all of our highest exponents, so our x squares. And I am going to color code these guys, okay? So negative x squared, positive 2x squared. Notice I also marked the sign that's in front of them. So negative 1 plus 2 gives me 1x squared. You don't have to put the 1 in front of it, but I choose to. Next, what is the next lowest exponent? It is x to the first power. So I have this 11x, and that is positive because there's no sign in front of it. And I have this negative 5x in the back. So 11x minus 5x is going to give me a positive 7x. And then finally, my very last bit is my constant terms. So I have a 13 and a minus 23, so it's going to give me minus 10. Okay? So I've written it in standard form, the exponents from high, so that's 2 to 1 to 0. Okay? So I did complete this from high to low, and now I need to classify it. Okay? This is a quadratic because the highest exponent is a 2. And if we want to be more specific, we can say that this is a quadratic trinomial because it has 1, 2, 3 terms. Excellent. Let's take a look at example number 2. Okay, example number 2. We are going to simplify this and classify it. So the first thing I'm going to do is just bring this down. It's in the front and nothing is going to change what is inside here, but that allows me to bring it out of the parentheses. And now I have a minus parenthesis. So I need to go ahead and distribute this negative 1. So I end up with negative 1 times 2y is negative 2y. Negative 1 times negative 13 changes that to a positive 13. And negative 1 times positive 5x is negative 5x. And now I'm ready to start combining my like terms. So I'm going to find my highest exponents. And I notice that I have two different variables here. So I'm going to go alphabetically. In the alphabet, x comes before y. So let's do those first. A positive 8x minus a 5x gives me 3x. A negative 3y and a negative 2y give me negative 5y. And then I've got this positive 13, and I can't combine this with anything, so I'm just going to bring it right down. And now let's classify this, okay? So what I end up having here is a linear, because the highest degree is 1, okay? And I have a trinomial, 1, 2, 3, I have 3 terms. Great job. Okay, Now, let's talk about multiplying. Multiplying. In this next example, what we have is really just distributive property, but distributive property that includes a variable on the outside. So this is when it's important for us to recall the exponents, okay? So what I'm going to be multiplying together is 3 times -2, and I'm going to get -6. And then I'm going to do c to the 5th power times c to the 1st power. And I need to add these exponents. So I get c to the 6th power. Okay. And finally, let's distribute the 3 to the -5, and that gives me -15. And I have no variable terms here to multiply this with, so I'm just going to keep it c to the 5th. Okay, and so we have written this in standard form. Let's go ahead and classify this. This is a 6th term, or 6th degree, binomial. And it's a binomial because it only has 1, 2 terms. Okay. The prefix bi means 2. Think about bicycle, has 2 terms. A tricycle, tri, has 3 terms. So look at our prefix. All right, and now here's example 4. We're going to take the examples 2 and 3, and we're going to put them together in a larger problem. So let's first start with our distributive property. So I've got 2w times -7w. So again, I'm going to handle the coefficients separately from how I handle the variables. So 5 times -7 is -35. And then w times w is w squared. Okay. All right. Now let's do the next part. 5 times -3, times +3 is a positive 15. And then I have w to the 1st power times nothing. So I'm just going to leave that there as a w. Let's do the second part. Distribute again. I have -2 times 13. So that's going to give me a -26. W times nothing is just W. And distribute one more time. -2 times -9 is a positive 18. And then W times W squared. So that's W. And then I'm going to add them 1, 2, 3. All right, great job. Now my last step here is I need to write this in standard form. So I'm going to do my highest exponent first, which is a 3. So 18w cubed. All right. Now I am going to combine anything. Let's see. Oh, w squared isn't going to combine with anything. So let's just bring that down. -35w squared. And then these will combine. So I have 15w minus 26w, which is going to give me a -11w. And that is my final answer. Let's go ahead and classify it. This is a cubic because the exponent, the highest one is 3, the degree, and it is a trinomial because it has 3 terms. So cubic trinomial. All right. So I'm going to go ahead and just pop these rules up here as a reminder for you. So here's what we did. We added exponents and we multiplied coefficients, even when we were doing our distributive property, okay? We multiply the numbers, the big numbers in front of the variables, and we add the exponents above the variables. That is how we have to do this, only when we're multiplying. So now let's review either our box method or our FOIL method. Now, when you refer to this as FOIL method, I want you to make a note that this only works using that acronym FOIL with two binomials. Okay, if I multiply a binomial and a trinomial together, I can't use that FOIL acronym. So really the official name for the FOIL method, what we're actually doing is distributive property of polynomials, okay, when there's more than one term. So let's go ahead and look at some examples. All right, so let's look at this FOIL method, and then we're going to look at this box method. Both methods will get you to the same solution. It does not matter to me which method you choose to use. They are equally as good. The box method is a little bit more visual. The FOIL method is a little bit more algebraic if you're able to keep yourself well organized. Okay, so I have the same problem, x plus 2 and x minus 3. X plus 2 and x minus 3. And we're going to solve this same equation using both methods. All right, so I'm going to zoom into FOIL method first. So here's what the FOIL method says. It says that we are going to multiply these together and we are going to end up with 4 different unique terms, okay? Let me explain to you why this is simply just the distributive property. Okay, so I have my first term, which is my x. So I'm going to multiply that to the first term in the second binomial. And then I'm going to multiply that same first term by the second part of the other binomial. So really, I'm just taking this x and multiplying it with each of the parts in here. So this is x times x, which is x squared, and x times negative 3, which is negative 3x. Now let's do the other two. So the inner and the last. So I'm going to do this second term of the first binomial, and I'm going to multiply that by the inner term of the other one. So 2 times x is a positive 2x. And then 2 times negative 3 is negative 6. And they call this last because 2 and negative 3 are both the last terms of their binomials. And then from here, what I need to do is combine my like terms. Negative 3x plus 2x is negative 1x. And then you can just bring down everything else. X squared minus 6. And that's your final answer. So that's using the FOIL method. Let me show you the same problem using the box method. All right, so here's the box method. So what I'm going to do this time is I'm going to set these up into the box method. So I'm going to take this very first binomial and I'm going to put it on the top. It doesn't matter where you choose to put it, top or the side, but we're separating these terms out. Then I will take this second binomial and I will put it down the other side. Okay, And now I have to do my multiplication. So I'm going to fill this in. This first box is x times x, which is x squared. This box on bottom is negative 3 times x. So negative 3x. Okay, let's do the second set. X times 2 is 2x. And then negative 3 times positive 2 is negative 6. Okay, and finally, I want to point out to you something, that whenever you set this up correctly, you should have some like terms on the diagonals, okay? So to save myself some writing, I like to just highlight the diagonal and then write down here what it equals. So negative 3x plus 2x is negative 1x. Okay, and that's what I got from combining. All right, now I take the other terms, the x squared, and I put it in the front, the minus 6, and I put it in the back. And so that way it is in standard form. And I've simplified everything. So, this is both of our methods. Now, an official name for the box method, I just call it that. It's really the area model, okay, for multiplying polynomials. So if you happen to Google that for more examples, look up the area model for multiplying polynomials, okay? So here is just the very super most important thing for you to remember here. When it comes to which method you do when you're solving your own problems, it does not matter to me in any way whatsoever what you choose. This is 100% your choice. Okay? All right, kiddos. So let's take a look at example 5. I'm going to do example 5 using the box method, and then I'll do example 6 using FOIL. I'll kind of go back and forth a little bit for you, okay? Okay, so the box method. So let's just set one up together. So I am going to have a box like this. I'm not perfect. Do, do, do. Okay. And so we are multiplying them. Okay, so just pick one to go along the top, 4x and negative 7. Pick the other one to go down the side, x plus 3, and then we need to fill in the middle. Okay, and you can do these in any order that you want to. You could say x times negative 7 is negative 7x. 3 times negative 7 is negative 21. X times 4x is 4x squared. 3 times 4x is 12x. As long as you understand what you're multiplying, okay? Whatever is the top of that column and whatever is in front of that row is what is being multiplied. Okay, let's do our combining like terms now. So I see a 12x and a 7x, and that's actually minus. So this is going to give me 5x. So let's write my final solution in standard form. I have 4x squared, positive 5x, and minus 21. And it helps me to actually see when I highlight my like terms and then circle this, that I've used all 4 of these terms. Okay. And so this is my final answer. Let's do the next one using the FOIL method. Okay. So here is an important note for you. Whenever you see a square above something like that, it means that you have 2 of whatever is in front of this. So in this case, I have a parenthesis in front of the squared. So I need to write that parenthesis out 2 times. X plus 4, x plus 4. And now I'm ready to multiply. Okay. If you don't write it out as 2 of them like this, a lot of students they just square it. They distribute the squared, which we can't do when we have a binomial because of this plus sign in the middle. The answer will not be x squared plus 16. I'll show you. If you do it like that, you're going to be missing some part of your answer. So let's do this together, the FOIL method. Okay, so I'm going to go ahead and distribute my x term to the first part of the second binomial. So x times x is x squared. Let's do it again, but share it with the back term. X times 4 is 4x. All right, now let's share the second term, the 4. We're going to multiply it with each term again in the second one. 4 times x is 4x. 4 times 4 in the back there is 16. And watch what you would have missed here. 4x plus 4x. This gives me 8x's. You still would have ended up with the 16, and you still would have ended up with the x squared, but you would have been missing this 8x in the middle. So that's why it's so important to write it out, okay? Write it out as 2. Alrighty. Okay, let's do example 7, and I am going to do this using the box method or the area model. Now I need to be careful. This time now I have 3 terms, okay? So, there we go. So I've done it like this. So I did 2 across and 3 down. You could have done it the other way as well. You could have done 2 down and 3 across. Either way. The important part is that we fill it in the correct places when we fill it in. So x plus 4, let's go ahead and put that on top. And then I will take this trinomial and put it down the side. So x squared plus 3x minus 6. And now I am going to do the exact same, whoops, I meant to zoom in. I'm going to do the exact same thing here as I did in this example up here. I'm just going to have more terms, okay? Okay, so if you want, I'll start on this back side. X squared times 4 is 4x squared. 3x times 4 is 12. 3 times 4 is 12. Keep the x. Negative 6 times 4 is negative 24. All right, now let's fill in the one closest. Sometimes visually I find doing the one in the back first makes it so that you don't have to overlook and ignore a bunch of numbers here in the middle. They're just not in your way yet. Okay. Let's start at the bottom and work my way up then. Negative 6 times x is negative 6x. Positive 3x times x is 3x squared. And then x squared times x to the first, we got to add those exponents. I get x cubed. Okay, so let's talk about our diagonals now. So I see 3x squares and 4x squares. So I do have a diagonal there. But wait a minute, I see another diagonal. I see negative 6x's plus 12x's. Okay, so when I do a 2 by 3, something kind of unique happens, and I end up with more than one diagonal set that can be combined. So let's go ahead and write these in standard form. I have my x cubed. Next, I'm going to combine my square terms. So 3x squared and 4x squared. Remember, we're keeping the x squared and we're just going to add the numbers now. We're done with our multiplying step. Now we're adding. So that's 7x squared. So plus 7x squared. Okay. Negative 6x plus 12x gives me a positive 6x. And then I've got negative 24. And so I have written this in standard form. Excellent, excellent job. Okay, let's do my very last problem. I'll do this with the FOIL method again. And note that I did put here that this is a special case. This is a special case. And I'm going to talk about why in just a minute when we solve it first, okay? So let's do my distributing. 2w times 2w is 4w squared. 2w times negative 1 is negative 2w. And now I'm ready to distribute this term, this 1. So 1 times 2w is a positive 2w. And then 1 times negative 1 is negative 1. I'm starting to run out of ink here. All right, so check out what happens. I have a positive 2w and a negative 2w. And this equals 0 when I add them together. So when I have a binomial that is the exact same numbers in the front and in the back terms, so same exact terms in the binomial, but one is positive and one is negative, that is when I lose these middle terms and I just end up with 4w squared minus 1. This is a special case, okay? So if you can recognize it, then you are able just to say 2w times 2w is 4w squared. 1 and negative 1 is 1. Now, it doesn't affect your answer if you still work it out the long way just to feel more safe and secure about your work and your answers. But if you're able to recognize that shortcut, it's good to know. All right, kiddos, there is a practice assignment posted for you on Canvas. I hope that this really quick review of working with polynomials helps us move a little bit more forward in our unit a little more quickly. If you do need extra assistance or practice and review, it is posted for you in Canvas, and I just want to show that to you. If you go under the 5-1 practice, it is not a requirement here, but this is an amazing resource. If you click on this, What we just did today was addition and subtraction of polynomials, multiplying and special products. So we just did these 4 topics in one lesson, and they walk you through methods step by step. They also explain how to use algebra tiles if you're more of a visual learner. And they walk through the distributive property the same way that I did. So these are all really great ways to review. And if you feel like you need extra practice, check this out. Adding and subtracting polynomials. Come down here, grab a sheet of scratch paper, work out this problem, and once you think you have an answer, select it, and it's going to tell you immediately if that answer is right or wrong. Okay, so you can get that immediate feedback without it affecting your grade. I really hope that this helps, guys. Alrighty, our next unit will be on factoring. So until next time.